Let's do another example of selective precipitation. So here we have seawater, and contained in seawater is about 0.059 molar magnesium chloride and about 0.011 molar calcium chloride. Now, magnesium chloride and calcium chloride are soluble in water, so they'll dissociate completely to form magnesium 2+ and chloride minus ions and calcium 2+ and chloride minus. So now say we want to precipitate out the magnesium 2+ ions. So we have a mixture in our beaker of magnesium 2+ and calcium 2+, both dissolved. And we want to precipitate out the magnesium 2+, leaving the calcium 2+. Well, we can do this because of the difference in the KSPs for magnesium and calcium compounds. So if we go to our table and look up compounds that are only slightly soluble that contain the same anion for calcium and magnesium, we see that magnesium hydroxide has a specific KSP, and calcium hydroxide has its KSP. So magnesium is 2.1 times 10 to the minus 13th, and calcium is 4.7 times 10 to the minus 6th. So now you can see the disparity in the equilibrium constants. So calcium hydroxide is much more soluble than magnesium hydroxide because the equilibrium constant is so much greater. Therefore, we can start to precipitate out magnesium hydroxide, leaving the calcium in solution. And we want to find out what concentration of hydroxide ion will start precipitating out magnesium. Well, we can just look at the equilibrium expression for magnesium hydroxide. So that's the KSP for magnesium hydroxide, and we can solve for the OH concentration knowing the magnesium 2+ concentration. And the magnesium 2+ concentration is this right here, because that's how much we have dissolved in water. So we put that into our magnesium 2+ term, and we solve for the OH minus concentration. So this is going to be equal to the square root of KSP for magnesium hydroxide divided by the concentration of magnesium, which is 0.059 molar. So this will give us the maximum amount of hydroxide ion that can be in solution for magnesium hydroxide. This is 1.9 times 10 to the minus 6th molar. So this is the maximum amount of hydroxide that can stay dissolved for magnesium hydroxide. So any OH concentration greater than 1.9 times 10 to the minus 6 and magnesium hydroxide will start to precipitate out because we have too much product in the magnesium hydroxide dissolution. So we'll start precipitating out magnesium hydroxide. Solid. It'll just precipitate out on the bottom of the beaker. We can keep adding hydroxide ion, and more magnesium 2+ will precipitate out in the form of magnesium hydroxide. There's a 2 here. So eventually, though, we'll get to a point where we have a high enough OH concentration to start precipitating out the calcium 2+. So let's see where that OH concentration is. So we do the same thing. We'll just solve the calcium hydroxide equilibrium expression. So we'll solve for the OH concentration for a KSP for calcium hydroxide. Now the calcium hydroxide concentration is 0.011 molar. So we put that in here, and we use its KSP. This is the square root of 4.7 times 10 to the minus 6 divided by 0.011. So that gives 2.1 times 10 to the minus 2. So if we keep the OH minus concentration below 2.1 times 10 to the minus 2, calcium hydroxide will not precipitate out because it will remain soluble. Therefore, we can precipitate out most of the magnesium 2+, leaving the calcium 2+ in solution.